What I hope to do in this video is to just read a SAT reading comprehension passage with you. And when you're actually doing the SAT, you're obviously going to read it silently and you're going to try to read it quickly but with good comprehension. But it might be useful to just read it out loud together, and I might just kind of think about how I think about the different things before I try to actually answer the question. So let's start. This passage is adapted from Ed Young, Turtles Use the Earth's Magnetic Field as Global GPS, written in 2011 by Kalmbach Publishing Company. All right, this is exciting. How do turtles use Earth's magnetic field as global GPS? And that's actually something I like to do. I like to convince myself that I'm very excited about what I'm about to learn. And in this case, I actually am. In 1996, a loggerhead turtle called Adelita swam across 9,000 miles from Mexico to Japan. That's impressive. Crossing the entire Pacific on her way. Wallace J. Nichols tracked this epic journey with a satellite tag, so they're using satellite tags to track it. But Adelita herself had no such technology at her disposal. How did she steer a route across two oceans to find her destination? So this seems like a pretty big question. How does a turtle with no GPS, without any navigation devices, go across 9,000 miles from Mexico to Japan? This is interesting. Nathan Putnam has the answer. Oh, that's good. Someone does. By testing hatchling turtles in a special tank, he has found that they can use the Earth's magnetic field, so they're using the Earth's magnetic field as their own global positioning system. Wow, so they're using the Earth's magnetic field as their own GPS. By sensing the field, they can work out both their latitude and longitude and head in the right direction. That's amazing. Putnam works in the lab of Ken Lohman, who has been studying the magnetic abilities of loggerheads for over 20 years. In his lab at the University of North Carolina, Lohman places hatchlings in a large water tank surrounded by a large grid of electromagnetic coils. In 1991, he found that babies started swimming in the opposite direction if he used the coils to reverse the direction of the magnetic field around them. This is impressive. So this is how they were able to tell that the turtles use a magnetic field as a way to tell what direction to go to, because if they reversed the magnetic field, then the turtles swam in the opposite direction. They could use the field as a compass to get their bearing. Let's keep going. I actually am interested in this. Later, Lohman showed that they can also use the magnetic field to work out their position. So not just their direction, but they can also work out their position. For them, this is literally a matter of life and death. Yeah, if they go to the wrong place, they might die. Hatchlings born off the coast of Florida spend their early lives in the North Atlantic Gyre, a warm current that circles between North America and Africa. If they're swept towards the cold waters outside the Gyre, I actually haven't heard Gyre, they die. Their magnetic sense keeps them safe. So if they go a little bit off track into the cold waters, they'll die outside of the Gyre. Using this coil-surrounded tank, Lohman could mimic the magnetic field at different parts of the Earth's surface. If he simulated the field at the northern edge of the Gyre, the hatchling swam southwards. Yeah, they don't want to go into that cold water. If he simulated the field at the Gyre's southern edge, the turtle swam west-northwest. These experiments showed that the turtles can use their magnetic sense to work out their latitude, their position on a north-south axis. So they could work out their latitude, their position on a north-south axis. If they had the magnetic field at the south end of the Gyre, they go north-northwest. If they're at the north end of the Gyre, they go south. They don't want to get out of that thing, because then I guess the water's going to be too cold. So that's how they can figure out how north or south they are. Now, where is my mouse? There it is. Now, Putnam has shown that they can also determine their longitude, their position on an east-west axis. Well, how do they do that? He tweaked the magnetic tanks to simulate the fields in two positions with the same latitude. So the same latitude is how far north-south, at opposite ends of the Atlantic. If the field simulated the West Atlantic near Puerto Rico, the turtles swam northeast. If the field matched that on the East Atlantic near the Cape Verde Islands, the turtles swam southwest. In the wild, Both headings would keep them within the safe, warm embrace of the North Atlantic gyre. This is amazing. Before now, we knew that several animal migrants, so animals that travel, from loggerheads to reed warblers to sparrows, had some way of working out longitude. So longitude is how east-west you are. But no one knew how. By keeping the turtles in the same conditions, with only the magnetic fields around them changing, Putnam clearly showed that they can use fields to find their way. So this is the crux of what they're doing. By keeping the turtles in the same conditions, with only the magnetic fields around them changing, Putnam clearly showed that they can use these fields to find their way. In the wild, they might well also use other landmarks like the position of the sea, sun, and stars. Putnam thinks that the turtles work out their position using two features of the Earth's magnetic field that change over its surface. They can sense the field's inclination, or the angle at which it dips towards the surface. At the poles, this angle is roughly 90 degrees. And if you imagine this is the Earth right over here, and if the magnetic field is doing like this is what they're saying. Listen, the magnetic field is doing like this. The magnetic field is looking like this. I'll just keep drawing it. So they're saying at the poles, this angle is roughly 90 degrees. So at the poles, this angle between is 90 degrees. And at the equator, it's roughly 0 degrees. You see it right over here. The field lines are parallel to the surface of the Earth at the equator, while they're going into the surface of the Earth at the poles. All right. They can also sense its intensity, which is strongest near the poles and weakest near the equator. Different parts of the world have unique combinations of these two variables. Different parts of the world have unique combinations of these two variables. Neither corresponds directly to either latitude or longitude, but together they provide a magnetic signature that tells the turtle where it is. This is fascinating. So what is, we have some diagrams right over here. This says orientation, and it's hard to read. It says orientation of hatchling loggerheads tested in magnetic fields. So West Atlantic, this is their orientation. The East Atlantic, this is their orientation. And then they have a description. Orientation of hatchling loggerheads tested in a magnetic field that simulates a position at the west side of the Atlantic near Puerto Rico on the left, so that's that one, and a position at the east side of the Atlantic near Cape Verde Islands on the right. The arrow in each circle indicates the mean direction that the group of hatchlings swam. So they do the mean, because they might not all swim in the exact direction. So the mean gives us kind of the central tendency. Data are plotted relative to geographic north, which would be 0 degrees. And you see, where on their east side, near Africa, they're going to swim away from that to, it looks like to the southwest. And then when they are on the west side, when they're on the west side, they swim away from that. So they swim to the northeast, just like that. So this is fascinating. So that's us reading the passage. And obviously I read it much slower and out loud, which you wouldn't typically do when you're taking a standardized test. But I think we understood what's going on there. They were able to establish that these, is a big question. How are these turtles able to go 9,000 miles without a GPS device? And they were able to test, and hey, they had the hypothesis, hey, maybe it's the Earth's magnetic field that they can sense how it's different in different parts of the Earth. And then they were able to test that by simulating Earth's magnetic field at different points of the Earth and seeing what the turtles did. And the turtles did what you would expect them to do. They behaved in ways that would keep them in the right direction as they migrate. So now that we, I think, have really digested the article, let's see if we can answer the questions. And I actually haven't seen these questions yet. I like to do this as fresh as possible so it simulates what you might go through when you're going to take a test. Now that we've read the passage, let's see if we can answer some questions around it. So question number 1. The passage most strongly suggests that Adelita used which of the following to navigate her 9,000-mile journey? So we remember that, if I remember correctly, the passage started with Adelita. Adelita was this turtle, and this 9,000-mile journey was across the Pacific Ocean from Mexico, from the west coast of Mexico to Japan. So let's see what they're talking about. So the current of the North Atlantic gyre Well, she couldn't have used the North Atlantic gyre. They do talk about that later on in the passage as ways that turtles in the Atlantic navigate across the Atlantic. But Adelita, what the passage started with, she was navigating across the Pacific. So she's not going to be using the current of the North Atlantic gyre. Cues from electromagnetic coils designed by Putnam and Lohmann. Well, they definitely talk about electromagnetic coils designed by Putnam and Lohmann in the passage, and these researchers use those coils to test whether turtles respond to it, that it affects their sense of direction. But Adelita didn't use the cues from electromagnetic coils. It's not like Putnam and Lohmann were on a boat for 9,000 miles with kind of electromagnetic coils near Adelita and using that to tell Adelita how does she navigate her 9,000-mile journey. It's not like she had access to these things. She did it on her own. The inclination and intensity of Earth's magnetic field. Well, that's what the whole passage is about. It kind of starts off with, isn't it amazing that this turtle can navigate this 9,000-mile journey on its own without some type of a GPS device? And then it uses the research in Putnam to Lohmann to show that the turtles are able to do this by using the inclination and intensity of Earth's magnetic field. So that looks right. Now let's look at the last choice. A simulated magnetic signature configured by Lohmann. Well, once again, this is like choice B. Adelita did not have access to technology from the researcher or Lohmann, so she was off by herself in the Pacific. All right, number 2. Which choice provides the best evidence for the answer to the previous question? So once again, the answer to the previous question is that turtles use the inclination and intensity of Earth's magnetic field. So what's the best evidence for us to feel good about that turtles actually do use the inclination and intensity of Earth's magnetic field to navigate across the Pacific or to navigate across an ocean? So let's see, lines 1 through 3, starting in 1996. Let's see, lines 1 through 3. So this is line 1 right over here. They give us every 5th line. In 1996, a loggerhead turtle called Adelita swam across 9,000 miles from Mexico to Japan, crossing the entire Pacific on her way. Yeah, this is what they started off with. It was an amazing statement. This was kind of starts to serve the problem to it. Like, isn't this amazing? But how does this happen? But this doesn't give evidence or explain why or how they use the inclination and intensity. So let me scroll back. That doesn't give evidence that they use the inclination and intensity of Earth's magnetic field, so I'm going to cross that one out. Lines 30 to 32, starting with using and ending with surface. Let's see, lines 30 to 32. Let's see, lines 30 to 32. Using his coil-surrounded tank, Lohmann could mimic the magnetic field at different parts of the Earth's surface. Well, we later do use this, Lohmann uses this technology that he's developed to test whether turtles respond, but this sentence by itself isn't providing evidence. It's just starting to say that, hey, Lohmann can mimic magnetic fields at different parts of the Earth's surface. So I don't think this is evidence either. I'm sorry, I have to kind of keep scrolling back and forth like this. Lines 53 to 55. In the wild, stars. Let's see. 53 to 55. 53 to 55. So let's see, that's this right over here. In the wild, they might well also use other landmarks like the position of the sea, sun, and stars. Well, if we remember, this is when they said, look, the turtles use the magnetic field, and they might also use this other stuff. Like, the stars, the position of the sea, sun, and stars might also help them. But once again, this isn't evidence for us believing that they use Earth's magnetic field. These are just other things that they might use. So let me just cross that one out. So deductive reasoning is probably going to be D, but let's check it out. Line 64 to 67, starting with neither. Line 64 to 67, starting with neither. So that's right near the end. Neither corresponds directly to latitude or longitude. And when they're saying neither, they're talking about different parts of the world have unique combinations of these two variables. And those two variables are the intensity of the magnetic field and the angle of the magnetic field. So neither corresponds directly to either latitude or longitude. Where they're saying either the intensity or the angle, but together they provide a magnetic signature that tells the turtle where it is. So this is the closest that I would say to actually providing evidence that the angle and intensity of a magnetic field can provide a signature to turtles to tell them where they are. So I like that one. It's actually the best of all of these. So I would go with D. As used in line 3, tracked most nearly means, all right, let's check out line 3. As used in line 3, so in 1996, a loggerhead turtle named Adelita swam across 9,000 miles from Mexico to Japan, crossing the entire Pacific on her way. Wallace J. Nichols tracked this epic journey with a satellite tag. So he put a tag on this turtle and then was able to track it. So let's see. Tracked. As tracked most nearly means followed, not hunted. He's not trying to kill the turtles or anything. It's not like he's traveling over the turtle, and it's not like he's not searching for the turtle. He actually knows where the turtle is because he has a satellite tag on it. So he followed the turtle. All right. Based on the passage, which choice best described the relationship between Putnam's and Lohmann's research? Well, they seem to validate each other. They were both working on magnetic fields and how magnetic fields can be used by turtles to navigate. So the first one says Putnam research contradicts Lohmann's. No, that's not the case. Putnam's research builds on Lohmann's. So this one seems interesting. Actually, I'm going to go back to the passage to make sure that it was Putnam building on Lohmann versus Lohmann building on Putnam. Lohmann's research confirms Putnam. This could be interesting as well. Lohmann's research corrects Putnam's. No, it wasn't like the passage said that Putnam's research was wrong. So we can rule these two out. But let's revisit the passage a little bit, just so that we can make sure we understand the work. So they told us, how did she, Adelita, steer across two oceans to find her destination? It says Putnam has the answer. By testing hatchling turtles in a special tank, he has found that they can use the Earth's magnetic field as their own global positioning system. By sensing the field, they can work out both latitude and longitude and head in the right direction. And then Putnam works in the lab of Ken Lohmann. So Ken Lohmann is his advisor. He's his mentor. So I'm starting to feel that he probably built on the work of Ken Lohmann, because Lohmann has been studying the magnetic abilities of loggerheads for over 20 years. So Putnam is the junior researcher, so I think he's building on the work. He's building on the work of Lohmann. He works in Lohmann's lab. Lohmann's been doing this for 20 years. The author refers to reed warblers and sparrows in line 49 primarily to, so let's see where they do that. Line 49, reed, so let's see. Before now, we knew that several animal migrants, from loggerheads to reed warblers to sparrows, had some way of working out longitude, but no one knew how. All right, so they're giving these other examples to say, hey, turtles are not the only ones that have this mysterious ability. So contrast the loggerhead turtle's migration patterns with those of other species. No, that's not what they're trying to do. Provide examples of species that share one of the loggerhead turtle's abilities. Yeah, this is feeling pretty good. Suggests that most animal species possess some ability to navigate long distances. No, they're not saying most animals. They're just saying that there are some other species that have this amazing ability. So they're not saying that most species. Let me just cross it out like this. Illustrates some ways in which the ability to navigate long distances can help species. No, they're not saying that the reed warbler or the sparrow, because they can travel a long distance, are able to do this or that or find more food. They're just saying, hey, turtles are not the only one. There's other species that also can do this. So I'll cross that out.